Okay, can you believe we have a 2-day unit and then a review and then a test again? Yes, it's true. So this is going to be a really short one on polynomials. You know what poly means? Multiple. Usually means like many. Okay, polynomials, that means obviously many nomials. What the heck is a nomial? Well, have you heard of a monomial or a binomial? Trinomial? All right, here's a monomial, 5x. That's got one term. Okay, 5x squared plus 3x is a, take a guess, binomial. When I add like 7 to it, now it's a trinomial. Okay, and what's different? This is just a quadratic. We've done that before. All right, it's just a parabola. That particular one will probably be kind of nasty to graph and stuff, but it's just a parabola. Well, all we're doing really is moving up a notch. So now we're doing things that are like x to the third and graphing things that start with x to the third, or graphing things or other stuff besides just graphing, but that go like to the fourth. And you'll know what that looks like by the end of the next 2 days. Okay? So instead of just quadratics where you got parabolas, now you got lots of curves in these things. All right. So this is the official math way to say this. It's an expression constructed from one or more variables. So it could have 2 variables in there if we wanted to. And using the operations of addition, subtraction, multiplication, and constant positive whole number exponents. All right. So given that last little part, positive whole number exponents, do you get that guy kind of sticks out? So that guy's not a polynomial. You got to have positive exponents, and they have to be whole numbers. So that's a fraction, so it's out. That guy's out. What else is out? Good question. I know it says polynomial, and that really bothers me too, because poly means many, but a monomial is still a polynomial. So I know it bothers me too, but this is okay. This one's okay, this one's okay. I guess that only leaves kind of this one. If we multiplied that one out, then really the question is, would it have weird exponents? No, it wouldn't have weird exponents. So therefore, it's a polynomial. Okay, so what you're looking for is if anything has a weird exponent on it, like a 3/4, or a negative exponent, or like a decimal exponent, anything that's kind of a weird exponent, you're going to have a problem. All right, notice it says positive. Can it have an exponent of 0 then? All right, so let's move on. The degree of a polynomial. The degree of a polynomial is the value of the largest exponent. We've already looked at one type of polynomial this semester, which is quadratics. So this one is a quadratic like we've been used to. What's its degree? 2. This is called degree 2. Basically, you just pick the biggest one. Notice there's a 1 there. So we could have had, the most common mistake here is people think you add them. You do not. You just pick the biggest one. So this is degree 2 because its biggest power is at 2. All right, so what's the degree of this one? Degree 6, just pick the biggest one. How about the degree of that one? Be careful. 4. Now, this one's different because that's kind of nasty. Usually the lead one, the one in front, has the biggest power, but this one, it isn't. Now, if you're to write it in standard form, you are supposed to write it this way. All I did is rearrange these first 2 terms. You're supposed to put them in order with the biggest one first. Then, do you guys know what this thing in front of a number is called? Like a 7 there? In front of a variable, sorry. The thing in front of a variable is called something starts with a C. Not a constant. Nope. Constant is this last number that doesn't have a variable. Coefficient. A coefficient. All right. So this has a coefficient on it. It's not a negative. What's the coefficient? -1. Okay. Now that lead coefficient is going to become really important in a minute. I'll tell you that later. But now look at this one. The most common mistake answer is that this would be degree 3 because, well, it's the biggest exponent that I see. But what we haven't told you is that if you multiply it all the way out, it'll be the biggest exponent that you see. So imagine for a moment that we were to multiply this all the way out. You don't actually have to. But if you did multiply it all the way out, what's the biggest exponent you'd have? Well, here's how you do it. You say this, when you put it to the third, you get how this would have an x to the third in it. And you would then multiply it by this x, which is only to the first. And x to the third times x to the first means you would have a lead coefficient, the biggest one. And this is also, there's a negative on there, so I have to be careful of that. Negative x to the fourth would be my lead coefficient. So now I know what degree it is, which is what? 4, degree 4. Okay, what I just did there? I acted like I was going to quick multiply this thing out and just quick and dirty to find the lead, the biggest one, the lead coefficient. This would be an x third, and this would be an x to the 1, and an x to the third and an x to the 1 would make an x to the fourth. And I threw on that negative in front because I know that later on you'll need to know the lead coefficient. If it's negative, it's going to mean something. Okay. And this one is all the way multiplied out, so it's really easy. What is the degree? 4. And what is the lead coefficient? Negative 5. The number that's on the biggest degree. Okay, and by the way, is this a monomial, a binomial, or a trinomial? It's all one clump. That is a monomial. Mono, 1. Okay? It's not like if there was pluses in here, then this would be a trinomial. Because pluses separate, or minuses separate terms from each other. But this one's all one clump. That is a monomial. This one was a 1, 2, 3, 4 part one. There's something bigger than trinomial. Quadnomial. Yes, but actually, even though quadnomial's right, usually after we get bigger than 3, we stop naming them trinomial, quadnomial, quintinomial, and you just say polynomial. But single ones are monomials, doubles are bi, triples are tri, and after triple we usually just go back to polynomial. So this is a polynomial. Okay. Do you get that every graph has a way that it begins and a way that it ends? The end behavior of a graph is how it comes into it and how it goes out of it. Okay? And we're going to keep it simple. It's really awful when people try to do this with increasing and decreasing because it's so tricky. Like you'd think this was increasing because it's up high, but it's actually decreasing right there because it's going down. So you don't want to get into the words increasing or decreasing. Don't do that. Just simple. Up and down. And so this one's up, and then this one's down. That's all we're going to be saying about their end values is whether they're up or whether they're down. Okay? So think about a classic graph like x squared. On its ends, it's up and up. Okay? On a classic graph like, yikes. Classic graph like the absolute value graph, up and up. Upside down parabola, down and down. All right, so these are just, you've seen these forever. It's just we're starting to name their end behavior. And it's just up and down. So you usually say the left one first. So what's this one? Down, down. What's this one? Up, up. What's this one? Down, up. Make sense? That's all now, here's the part that's predicting whether it's going to be down or up. That's the hard part. Looking at a graph, oh my gosh, so easy to say if it's up or down. All right. I kind of like this. Grab your graphing calculator, and I can tell you whether the graph's going to end up or down, I can tell you a lot about any graph. So like for instance, you could tell me, Mr. Server, negative 3x to the 5th plus 4x plus 7 plus, or 7x minus 9, and I can tell you all about the graph, even without a calculator. And you're going to double check it by actually graphing it. Okay? So to prove it that I'm not just making this like, you know, like I'm not just making up into ones I already know the answer to, I want you to give me a graph, and we will all type it in. Something somewhat complicated. Have at least 3 terms, maybe 4. Okay? But if you're going to give me 4x squared, I'm going to know it's a parabola, so boom, it's going to be so easy. 4x to the, okay, keep going. All right, cool. Everybody graph that, and I can tell you what it's going to look like, basically. Okay, it is going to be down on the left, and it's going to be up on the right. And it's going to have, it's going to go through -7 on the y-axis. So it's going to touch at -7. So I knew this one was down, up, and goes through -7. Now I want to see if any of you can look at that and start to make predictions like I just made. Okay? So let's try another one. Now, first of all, did you verify it on your calculator? Can I see what yours looks like? All right. So it basically looked kind of like that, except it went through, not exactly like that because it didn't go through that y-intercept. All right. Something like that. All right. Give me another one. Anybody? Something complicated, but the only thing is that your last number needs to be smallish, otherwise it won't stay on our graph. Everybody have to adjust their window, and it's a pain in the butt. So make your very last number kind of small. Yes? No problem. Bring it. Okay. You could have had a lot of terms in there because you could have x to the 23rd, you could add an x to the 22nd, and then x to the 21st, and you could have thrown in an x to the 5th, and all that stuff. And I can still tell you the answer. I know that this one is also down on the left, and it's up on the right, and it goes through -3 on the y-intercept. Now, at least some of this I know you're starting to figure out. Can you tell by what I was looking at to know that that was right? Yes? The largest power, okay. So if it's even or odd, so what's your theory then?
Even ones will be up unless there's a...
Even equals up, up, unless what? Okay. What's your theory on odd ones then? Odd are all going to be down, up? Just all? You've nailed it, young man. That's it. That's how you tell. And you all are going to be tested on that on Thursday. Okay, so let's make sure you get what he just said. If you give me an even one, I know that both ends are going to go the same direction. Instead of saying up, up, I just say that they're going to go the same because they're not always up, up. It's either up, up, or down, down. All even ones are going to be up, up, or down, down. And how do you tell? If there's a negative in front. And the way we say it, you said it, your way works, but the way we say it usually is there's a random one I just came up with. What we usually say is this means that they're both going the same direction. Either up, up, or down, down. This, it does not tell me where both ends go. The lead coefficient tells me where the right end is going to go. and then the other end has to follow logically. Okay, so if you start with the negative, I guarantee you, no matter whether this is odd or even, if there's a negative there, it's going down on the right. Always. If there's no negative there, it's going to be going up on the right. Always. Okay, so this right here tells us the right end. Always. Then this tells me whether they're the same, if they're even, or they're different if odd. Then, have you ever heard of the Midwest described as flyover country? It's kind of a sad thing. The people on the coasts kind of think that we're really boring in the middle of the United States and that the best parts are on the East Coast and the West Coast. And so they'll call the Midwest flyover country, as in that's the place you fly over when you're going from the one coast to the other coast. Sad, but it's true. Just so you should know it coming in from a Minnesotan that other people might say that of us and a lot of other states. But anyway, so flyover country kind of works for this too, because none of the stuff in the middle matters. It's all flyover country. That doesn't tell me anything about my graph. Now, does it actually change the graph slightly? Yes, it can change it slightly, but it doesn't tell me about the up or down. It doesn't tell me how it begins, how it ends. This tells me something, though. What's that? Y-intercept. The y-intercept is -7. Has to touch there. Remember, the y-intercept is where, fill in that sentence. X equals 0. This is really critical. It's going to help you next year, too. The y-intercept is where x equals 0. Because the reason this works is not because it's the last number. It's because it doesn't have an x on it. Because if all the things that have x in it will cancel. The y-intercept is where x equals 0. So when you have like this, what is the y-intercept? Well, it's where x equals 0. So then this cancels, and what's the answer? Y equals 0. Okay, so the y-intercept, if you don't have any number at the end, is a 0. Okay, and why I also don't like it because like this. If you say it's the number at the end, then I say, okay, so you're saying the y-intercept is 5 here? Nope. The y-intercept's not 5 there. The y-intercept is where what? Say it. X equals 0. So I put a 0 in, and I find out what it is. 3 squared is 9 plus 5 is 14. The y-intercept in this is 14. So don't just think it's the last number. Okay, but back to if it's all multiplied out. See, this one's not all multiplied out. If it's all multiplied out, it will be the last number. All right, so I want you, I'm going to give you, instead of a stump the teacher, now it's a stump the kid. I want you to make a sketch that could work for this graph. Remember, flyover country. Doesn't tell you anything. Just make me a little sketch, no calculator. What would that thing look like? Okay, let me think now. Yours works. Yours works. Yours works. Yours has got, it's up on the right, and we don't want it to be up on the right if you look at the graph closely. Good. 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 Make an XY axis. Otherwise, I think you got it right. Good. 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 I was checking 3 things on everybody's when they were showing it to me. Good. 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 Several people haven't shown me their try yet. It's okay to be wrong, by the way. I'm not going to beat you or think worse of you. Good. Good. You've seen me make tons of mistakes, right? Good. Good. One of your ends is going the wrong way. Okay, so would you agree that this lead thing tells me it's got to be down on the right? That's what that negative does. It tells me just the right side. I don't even have to look at the rest of the graph. I just need to know that. And I know it's going down on the right. Now, how about this? What does that tell me? Are they same or different? The odd number tells me they're different. That makes this other end must be up. The last thing I go by is this. And that means that it's got to have a 3 as its y-intercept. So it has to touch about there. So then I'm just going to connect mine by doing like that. There we go. Now, was that a very detailed graph? No. It just tells me a few things. We'll get more detailed tomorrow. All right. So if you take a look at this, we know x squared. We've seen it a bazillion times, right? But now look at it with new eyes. You now know something more than you knew before. Do you get how it leads with a positive and therefore it must go up on the right? Do you get how it's even and therefore they must both go up? And then do you get it has a plus 0 at the end and therefore it must have a y-intercept of 0? You see how it was following those rules the whole time and you just probably didn't ever think of it that way? Okay. How about this guy? First thing you notice is that lead coefficient's negative. So now you know it's doing what? Down on the right. That you don't know the down yet until you look at this. That tells you they're both the same. It's down on the right, and if they're both the same, they must both be down. And then the y-intercept of it, plus 0, it's going through 0. Okay. So if you look at x to the third, notice the lead's positive, must be going up on the right. That's odd, must be going different directions. Y-intercept 0, must be going through 0. I think you get the idea. Let's go up to something a little crazier like x to the fifth. Doesn't it seem like this plain x to the fifth? Let's look at the one on the left there, number 7. Doesn't it seem like that should be different than x to the third? But x to the fifth and x to the third pretty much look the same. Did you notice that if this could be x to the third or x to the fifth, what else could it be? X to the 7th, x to the 11th, x to the 9th, okay? But if it looks like this, you now know that it might not be x squared. It might be, what do you think? X to the 4th, or x to the 6th, or x to the 8th. All right, so this is x to the odd, and this is x to the even. Notice they both go up on the right. What do you know about their lead coefficient then? Must be positive. Okay, good. Making progress. This guy. Would you agree it's down, down? Therefore, its equation had to start with a what? Positive or a negative number? A negative number because it's down on the right. Okay. Since they're both down, would you agree that it has to be an even power? So it must be like y equals negative, and I don't know exactly, but let's say x to the 4th or something even. Then there's a whole bunch of flyover country. And then, what's the y-intercept here? Can you tell from the graph? If that's negative 5, it looks like it's touching right about there. Maybe about negative 7. I know it's off a smidge, but... So I know my graph would have to be something like that. All right. But one of the important things that we're going to be doing is telling increasing and decreasing. In the United States, we always read from left to right. From left to right. So if I look at any little part of this graph, as I read from left to right, do you get that this part right here is going up as I read from left to right? So that part is increasing. I'd like you have this picture on your iPad, right? I'd like you to also take a green pen and I want you to highlight the areas that you see that are increasing. In green pen or some highlighter, I really don't care if it's green, but you're going to change colors in a second to do the decreasing ones. So just like I just did for the increasing, do both parts that are increasing in green, and do the ones that are decreasing in a different color. Okay, I'm back with you. Hopefully you said it was increasing in those two areas, the two areas that are in green now, and it was decreasing, I'm going to use blue, there, and there. Oh, and there's another increasing area, sorry. I forgot. This is increasing the whole time too. All right. You with me so far on what's increasing, what's decreasing? Now, how do you say it mathematically? What you say is, what we're saying is it's increasing or decreasing. Like, I'm going to pick this area right here. And I'm going to say it is decreasing from here to here. Now, those lines that I just made, those are x equals things. So, I'm going to pause for a second. So, this part right here, I have a choice between picking this to this or picking this to this. That's how you're going to say that little decreasing interval there. Do you think it should be the x's or it should be the y's? I have a feeling that I'm going to get a 50-50 answer here. I'd like you to, on your iPad, your gut, is it x or y? Don't say it out loud. Write it down. Zoom in on it, and I'm going to see how many x's there are and how many y's there are. Just to see how many people's gut feeling on this would be right. Okay, I'm just going to count x's and y's. So, okay. 1, 2, 3. I'm counting x's so far. 4, 5, 6, 7, 8 x's, 9, 10, 11 x's. It's about half of you. And one person said x and y, and the rest of you guys said y. So it's pretty much half and half. Yeah, so you guys don't know, and that's okay. But you need to burn this into your brain because that's the most common mistake on this test. And it's so easy. You just have to pick the right ones. It's the x's. X's. It's these numbers. I should now clear this off and show you for sure what I'm talking about. I'm saying that this interval right here, this blue one, where it's going down, you would say it's decreasing from negative 3.6 to negative 0.9. Because it's from, here's negative 3.6 is right there. See, that's where negative 3.6 is. To, how far does it keep decreasing? Up until about here. Because see, if I were to extend these lines down, it's decreasing from like here to here. All right, so I don't know what your best way of remembering this is, but it is always going to be the x's for your intervals. All right, so then, how do you describe this next one that's going not in this little interval? Ooh, this is actually kind of cool. So this is like an interval thing. Do you get in this next interval? It's not going to quite fit widthwise, but do you get the green one that's going in this interval? Then you want the x numbers from here to here. Well, the x on this one's pretty obvious. You got to figure out what point is that, what comma what, and then write me the interval right here. What's this interval called? From what to what? Is it increasing? Turn it my way and I'll tell you if you did it right. Yes. 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 And a lot of you guys are saying 2, and that's what I would have normally done also, but we put a comma in there, so you were right on that. You put a comma in between them. All right. Yes. I think it's only to 1. I think it's only over 1. Yes. 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 Okay, people are getting it right. This spot right here is at 1, right there. That point is 1 comma 0. So it's the x's of it, so it's from here to here. So it's from negative 0.9 to 1, and you put parentheses around it. All right? So that's one of the places it's increasing from. It's increasing from, remember, these are all x's. Negative 0.9 to 1. And there's another spot it was increasing. From, where's that? It's going forever. From negative infinity, because it starts way over there, up until it hits here, it was increasing. From negative infinity until it hit here, which was negative 3.6. Remember, it's the x numbers. And x is going to negative infinity if I keep going that direction. So basically from the beginning of time until negative 3.6, it was going up. Decreasing. Decreasing from negative 3.6 to negative 0.9. That's from here to here, which is like from here to here. It was decreasing. And then the last place it's decreasing is from this spot to forever. So if that's from 1 to infinity, it's decreasing because it'll never stop decreasing. Yes, sir?
On that actual numbers, do you not need brackets?
Good question. The question really boils down to a debate. Do we want to have brackets on this or not? If we just focus on this little interval right here, that's going up, okay? Is it still going up when it hits the top? So the question is, should we include that top number or not? Or when you hit the very, very top, has it stopped going up and therefore shouldn't be included? See, that's what brackets versus parentheses are. Is bracket says it's included in the group. And can you prove to me that at the very, very, very top that it's still increasing at that moment? Isn't it also starting to decrease at that moment? And therefore it shouldn't be included? So anyway, we go with parentheses on these.
But also, do you join those by like Q or whatever?
It's a good question. Yes, but we're not tough on that. But yes, it's a good idea to have a U in between them. Thank you for noticing that. Okay, let's move to another one. See if without my help you can remember how to do where it's increasing. There's two places it's increasing and one place it's decreasing. It's too far away. I'll read you the answer in a minute. So I'll pause for a second while you try this one. Here's what you should have said. It's increasing in that little zone. That is from, remember, think of this as x's. How far this way did it start increasing? Negative infinity. To, it stopped increasing right about there, which I have to follow up here and find the x of it and say, okay, negative 2.1. Raise your hand if you had that part right. Okay, good. Next part, there's another spot that's increasing, and that's here. Okay, and that's from right here, and the x of it, that's 1 comma 0, and the x of it is 1. 1, 2, how far does it keeps going that way forever? Infinity. Probably a U is a good idea. Decreasing in this little zone, and that's, again, use the x numbers from negative 2.1, which means about here, to here, and that's 1. So from negative 2.1 to 1. Raise your hand if you had that right. Good. Now that it starts out kind of hard, but then once you get the idea that the increasing, decreasing is going to be your happy place on the test, because that's going to be the easy part. I'm going to skip that one because I think you guys got it. So, your assignment for today. Let's find it together. It's kind of weird because it's one gigantic worksheet, and you are doing parts 1, 2, and 3 for your homework for today. Okay, parts 1, 2, and 3. I'm going to pause while I can. Okay, so here is section 1 on the worksheet is basically about degree. Okay, and then section, and I hope those are easy for you. You just pick the biggest one. Just be careful that they sometimes rearrange them and the biggest power isn't always first. Okay, section 2, end behavior of functions. Basically, what we're trying to do is have you get an idea of how these look based on the negative in front being up or down on the right. And if it's negative in front, it's down on the right. And also based on the little power. And if the power is even, you know they go the same direction. All right. So you make a sketch of these, and then you describe the end behavior. So if I know, I don't even have to have the sketch to do this one. Right and the left. There's the two sides for all of them, right? The right side because of that negative in front, I know it's down. If you want to just abbreviate it D and U for up, that'd be fine. The left side, since it's even, I know they go the same way as each other. So if it's down on the right, it must be down on the left. Now for my actual sketch. There we go. There we go. Okay? I am okay with you sketching these instead of graphing these. That means that you don't have to have distinct points. That's the main difference between a sketch and a graph. I'm okay with sketches. All right, I'm going to clear my ink and go further. Oh, why didn't ink clear off of there? That's weird. I'm just going to use the eraser. Okay. All right. And then section 3, that's this part, which is our longest part. And it's a little long given how much time we have. Now, it is pretty easy, but I'm going to have you skip a few just to make you feel a little bit better about it. We're going to skip E and H. You can skip E and H. I need you to do all these other ones, though. All right. So let's do some of these together. Number 4, part A. Describe the end behavior of the following functions. That means just left side it's this, right side it's that. Make sure you consider whether it's even or odd and whether the leading coefficient is positive or negative. Okay, so that's all there is to it. Just left and right, I guess. Yay. So I can tell that one's up, up. Could you tell that? Because it was positive in front, the right side was up. I would always do the right side first. I mean, don't list it first, but always figure out the right side first because the lead coefficient is positive, so it's got to be up no matter what degree it is. Then I see it's even, so they must both go together. So if this one's going up, that has to be up. All right. So just don't get caught like on this one. The lead coefficient is actually the second one over because it's got the biggest power. So. Okay, that's all I have for you for today. I know it's kind of a long, intense day, but I guess the good news is that you learned a ton of stuff and we got your test back, and overall you really rocked the last test, so that's awesome.